Hi guys! We are going to start today with a warm-up just based on one that we did yesterday and one from a few days ago. So the first one is just a discount. So if you remember, whether we're doing tax or discount, you take the price. And for tax, you add because tax makes things more expensive. For discounts, you subtract because that's going to make something cheaper. So you either add or subtract depending if it's a tax or a discount. The price, again, multiplied by the percentage, okay? Because this piece, the price times the percentage, is going to give you either the tax, which you're adding, or the discount that you're subtracting, and then you add or subtract it from the original price. So this one is a discount. So our price is $85, so you start with that. Discounts make things cheaper, less expensive, so you subtract the price again, 85, times the percentage, which is 20%. Or, remember, you can do 85 minus 85 times 0.2 because you're going to move the decimal place 2 places to the left. That's if you don't know where your percent sign is, or you're not using a calculator that has a percent sign and you just have to use like a Google calculator, then you can just do the 0.2. Either way, you're going to get the same answer, so when you plug that in, 85 minus 85 times 20%, you're going to get 68, and that is how much you would pay in dollars for the camera. All right, number 2. This is two equal fractions or proportions. So yesterday we also did percent change and we did proportions, so we know how to cross multiply. So you can cross multiply when you have two fractions that equal to each other. You just have to be careful with this one because these are grouped together. The x plus 1 is all on one part of the fraction, so you have to put them in parentheses and group them together before you do your cross product. So we're going to do 4 times the quantity of x plus 1 equals, because you always set your cross products equal to each other, 3 times 8, which is 24. So once you write it like this, it looks a little different. You have to get rid of the parentheses first, which means we're going to distribute. So 4 times x gives you 4x, drop the addition sign. 4 times 1 is 4, and then equals 24. And then from here, you're just solving for x. So we're going to start by subtracting. And that leaves you with 20. And then the x is still being multiplied by 4. So you just divide both sides by 4 and get your final answer of 5. And then you're done. All right, today we are going to continue to solve equations. The difference today is going to be that these equations have more than one variable, okay? So we're going to say, here's this equation, solve for x, but the equation might have an x, a y, and a z in the original equation. So your answers are not going to just be numbers. You're not going to get something easy like x is 2. You're going to get something like x equals y plus z divided by 7. Okay, you might have something with other variables in it, but the steps to solve aren't any different than before. You just have variables to deal with instead of actual numbers. Okay, so if you have some blanks to fill in, go ahead and pause it and fill them in. You're still solving for the designated variable the same way as you would before. The biggest thing that I want you to make sure you do is I need you to highlight the variable that you're solving for. It's going to help you visualize what you need to do. So we're always going to start by highlighting the variable that we need to get by itself. Okay? Then you make sure that variable is all together in all the same places, and then move anything that doesn't have that highlighted variable to the other side, just like you would when you were solving anything else. Okay? Your answers are not going to be a single number. They're going to have numbers and variables. Make sure you understand that. So it's a little tougher because it's not like you don't know for sure, like, oh, I'm done. Like, I know this is my answer. It looks a little funny, but you have to just trust your solving abilities to understand that you know what you're doing and you know how to get a variable by itself. Okay, so let's look at number 1. It says 3x minus 4y equals 7, and it asks us to solve for y, okay? So the very first thing I'm going to do is I'm going to highlight the y, okay? That's the variable I need to get by itself. Luckily, it's only in one place, so I don't have to move any y's to get them all together. I just need to move anything that is next to that y on the same side of that equal sign as that y to the other side, okay? So just like when you're solving any other time, something that's directly connected to your variable, like the 4, is going to be the last thing that you move, okay? So we need to move the 3x first. This entire term, even though it has a variable connected to it, has to be moved to the other side all at one time. All terms are going to get moved in chunks. If we don't need any part of it, we move the whole thing. Like I don't need the 3 or the x over here, so I'm going to take the whole term and move it over. That term is currently positive, so in order to move it, just like any other time, you're going to subtract it. So we're going to subtract 3x from both sides. Be careful because that's going to leave you with a negative 4y. Do not lose that negative sign or that subtraction sign. Now, on the right-hand side, the negative 3x and the 7 are not like terms. Okay, the 7 doesn't have an x and the 3 does. So you cannot put them together. So I'm just going to write them out in a line. When you can't combine them, you just write them down. So just 7 minus 3x. Just write it all down. Re-highlight the y to remind us what we're doing. And now it's still not by itself. It's not the only thing on that side, so now we need to keep going. It's still being multiplied by negative 4. Well, the opposite of multiplying by negative 4 is dividing by negative 4, just like if you were solving normally. And then that leaves you with this whole chunk as your answer per se. The only thing I'm going to be picky about is that you're not supposed to leave a negative on the bottom of a fraction. That's not a proper way of writing something, okay? So what we're going to do is you have to take that negative and you have to transfer it to the top. We have two different terms on the top, so that negative is going to change the signs of both of those terms on top when we move it there, okay? So that 7 used to be positive, it is now going to be negative. The 3 was negative, so now it's going to be positive because that negative number we're transferring to the top changes all of that. But it leaves us with that positive 4 on the bottom, which is what we need for our final answer. And then you're done. It looks ugly, but that's it. Let's look at number 2. We are solving for b. So we're going to highlight the b's anywhere we see them. Okay? We only see b in one place, so that's good. So anything that's on the same side of the equal sign as this b, we need to move it over. The 7 is directly attached to the b, so that's going to be the last thing we move. So the only other thing is that minus x. So we're going to move the minus x by adding it over. If you look on the other side, there is a 3x over here, which means it's going to be added to that 3x because those will be like terms. So 3x plus x is just 4x. We're still solving for b, but we're not quite done because there's still a 7 there. So we're going to have to, it's being multiplied by 7, so we are going to divide by 7. When you divide over here on the right-hand side, there's multiple terms. You do not get to pick and choose what gets divided by 7. It all has to be divided by 7. So if you're dividing, you put it all over something. When I'm looking at what my answer is going to be, I do not see a negative on the bottom, and it looks fine as far as simplification, so that's just going to be it. It's just going to be that whole 4x plus 2 all over 7. And then you're done. All right, number 3. First of all, we're solving for a, so we're going to highlight the a. Ooh. If we look, there's a lot going on, okay? First of all, all of the things that are on the same side as the a are all connected to it. There's no addition or subtraction that we can undo first. It's all multiplication, so that makes it a little trickier. It might be easier for us just to get rid of the fraction to begin with. So the easiest way to get rid of a fraction is to multiply everything by the denominator, okay? So 1/2, if I don't want that 1/2, I'm just going to multiply both sides by 2. So on the left, 2 times s is just 2s. On the right, it gets rid of whatever was on the bottom and just leaves you with the top. Now in this case, my top was just 1. So if I multiply something by 1, it isn't going to change anything. I don't have to write 1at squared. Technically that's what's there, but I don't need it, so I'm just going to write the at squared. I'm still trying to solve for a. So a is currently being multiplied by t squared. The opposite of multiplying by t squared is dividing by t squared, just the whole thing. So I just divide it all, everything, by t squared. When I'm looking at my answer, I don't have any negatives on the bottom, and there isn't anything I can do to 2s over t squared. That's just what it's going to be. So that's my answer. Not the prettiest thing, but it is useful, and we're going to use it a lot this year, so we've got to get good at it. All right, these 3, I want you to pause and go through and do these 3 on your own. You're solving for b, then you're solving for x, and then you're solving for a. Okay, be careful on the 5 because the x's are in multiple places, so you're going to have to get them together first. So I would move this minus 3x over to the other side by adding it over, okay? Once you're done with those, then you can resume, and we're going to finish these 3 together. For number 7, we're going to solve for z, so we're going to highlight the z. It's only in one place, so we just have to move everything to the other side of the equal sign. So again, the 2 is directly connected to the z. That's going to be the last thing that we move. So we have to move the c, as in cat, first, and it's being added, so we're going to subtract it. When I'm looking ahead and thinking about going to be subtracting that c, I'm going to look over to the left where I'm going to be taking it. I do not see any like terms over here. There isn't going to be anything I can attach that c to, so I'm just going to have to put it on the end. So there's just going to be a long string of terms because none of them match, so that's okay. I'm just telling you, like, that's what it's going to look like. You just kind of eyeball it beforehand so you have an idea where you want to take it. So I'm going to subtract this c over. I already talked about we don't have any matching terms, so all I'm going to do is write them out in a long string. So 4x plus b minus c equals, and then over here I just have the 2z that's left. I'm solving for z. It's still not by itself. It's currently being multiplied by 2, so I have to divide by 2. Remember, when you're dividing with these, everything has to be divided by 2. You don't just get to pick and choose what pieces. It's all over 2. My denominator is positive, so I don't have to worry about that. So that's just going to be my answer. I can't do anything else. Don't try to overcomplicate them. When you think you're done, you're probably done. All right, number 8. We're solving for y. The problem is that y is stuck on top of that fraction with the a. Because we have a giant fraction bar, this giant fraction bar means that anything that was on top is stuck on top until we get rid of the denominator. So the way you get rid of a denominator, we just talked about it, is to multiply everything by that denominator. So I'm going to multiply both sides by 3. The whole point is that when you multiply something by the denominator, it cancels it, and you're left with whatever was on top. So in this case, I have the y plus a, which is good because I got it unstuck. It was stuck up on top, locked up there until I got rid of the 3. On the right, I have c times 3, which we just usually write as 3c. I'm still solving for y. The only thing that's still happening to it is that it is being added to a. The opposite of adding a is subtracting a. Again, when I'm looking ahead, I notice that the right-hand side does not have any a's currently, so it's just going to have to be put on the end. So I'm just going to subtract a. They are not like terms, so my answer is just going to be 3c minus a. And you're done. All right, one more. This one's tricky. My instinct, and probably your instinct too, is that you see parentheses and you automatically want to distribute and get AB plus AC. But then you look at what you're supposed to be doing. This is why we have to check it out first. I wanted to solve for A. In my original question, my A was only here. After I distributed, now I have an A in 2 places, and I just made my job impossible. Okay? I cannot take that A and distribute it if that's what I'm trying to get by myself. If you think about distributing as trying to give things away, right? We're trying to get that A all alone. I don't want to keep passing it out to other things if I want it by itself. So I do not, in this case, want to distribute. If I were solving for B or C, I would want to distribute. That would be perfectly acceptable because I would need to get rid of the parentheses to get in there. But I don't. I want to get the A by itself, so I don't want to give it to anything else. So I'm trying to get A alone, and I don't want to distribute it. But we do need to know what's happening to A. It is currently being multiplied by B and C together. Not just B, not just C, but both B and C together. So if it's being multiplied by B plus C, what's the opposite of multiplying by B plus C? It's going to be dividing by B plus C. And whatever you do to one side, you have to do to the other. Then, nothing is negative, no funky stuff, so that's just going to be your answer, P over B plus C. You don't have to have the parentheses on the bottom. You can if you want to. As long as they're both clearly on the bottom, you do not have to write the parentheses. And then you're done. All right, your homework is worksheet 3-4. Make sure you turn in this section of your notes. And if you have any questions, let me know. Bye, guys.